Hi all, this is section 1.2, the structural theory of matter. So what we have seen a lot of already in our chemistry careers is that in general chemistry, we don't really talk about molecular structure so much, right? What we talk about instead are typically things like, this should be like H2SO4, HCl, and maybe these things reacting with in water to give, so let's see, H2O, so give H3O plus and HSO4 minus. We deal in general chemistry a lot with inorganic substances that have a specific formula, and how they're connected isn't really talked about a lot in the class. We're just mainly worried with what the molecules actually are. However, in organic chemistry, we've totally changed our mindset because if you have two similar molecules, here I'm drawing dimethyl ether. So named because there are two CH3 groups attached to this oxygen. And I also draw ethanol, which is a favorite molecule of some. They have very different molecular properties, even though they have the exact same molecular formula. So their formula is C2H6O, but for instance, the boiling point of dimethyl ether is less than 0. In fact, I think your book says it is minus 23 degrees Celsius, meaning it's a gas at room temperature, whereas ethanol, its boiling point is equal to around 78 degrees Celsius. So a huge difference depending on the exact molecular structure of these molecules. And this is really the key point of organic chemistry, is that we need to train ourselves to be looking for how molecular structure is different between molecules, because that is going to change our or the properties of those materials. Should be section 1.2, sorry about that. Okay, so another thing that's important to remember is that certain atoms generally have similar connectivity patterns, such as carbon wants to make 4 bonds and be tetrahedral. We learned this in general chemistry. Nitrogen wants to have 3 bonds and be trigonal planar, or sorry, trigonal pyramidal. And something like oxygen is happy only having 2 bonds to being a bent molecule, like in water. And things like hydrogen and halogens, they only make 1 bond, and they're typically linear. I'm drawing the Lewis dot structures of these general connectivity patterns of these atoms. Now, it's important to remember when we're looking at these that we're going to quickly go into the numbers of bonds, numbers of electrons, and the geometries of these around these atoms, which is the V-separ formalism that we all learned in general chemistry as well. So still a lot of review, but getting kind of a small dip, or dipping our toes into the water of what it means to have structural differences in organic chemistry. So this has been section 1.2